Okay, this is Module 4, Homework 2. It's the last section of our notes before you're going to take Test 2. So make sure you've already done Module 3, and now you're finishing Module 4. And this is about complex numbers. So we're going to be introducing imaginary numbers. In the section before this, when we had the square root of a negative, our answer was D and E, or does not exist. And once we learn about imaginary numbers, we're not going to do that anymore. So once we do this section, you're no longer going to give D and E for an answer when you have a negative under the radical. So what this question will look like is our negative will come out. It will turn into an I. We'll end up with I square root of 4, and the square root of 4 is 2. So that's what we're going to be learning in this section. So the first thing is I equals the square root of negative 1. Okay, and anytime we see I squared, that's going to equal negative 1, which this doesn't happen for any real numbers that we work with ever. So anytime you see I squared, you are going to replace it with a negative 1. And the reason why this doesn't work with real numbers is a negative times a negative gives us a positive. And a negative times a positive gives us a negative. So we learned about this in past sections that you can never multiply a negative and a positive to get a positive. And anytime we multiply two negatives, we get a positive. So when we square this, if it's negative, we're going to get a positive. And when we square a positive, it should be a positive, but that's why this imaginary number is introduced. So then we can get an answer when we have a radical with a negative 1. Now, when we see I squared, that's the same as I times I, and we know that I is the square root of negative 1, so we have the square root of negative 1 times the square root of negative 1, and we've talked about anytime you have a radical multiplied by itself, it equals what's underneath that radical. So this is going to equal negative 1, which is the same thing that we have right here with our I squared. So this is just a little refresher. In the last section, we talked about anytime you multiply a radical by itself, square root of 5 times the square root of 5, it equals 5. Or the square root of x times the square root of x, that's going to equal x. Okay? So our first definition is going to be a complex number is one that can be written in the form a plus bi, where a and b are real numbers. So the imaginary part is going to be the part that has the I, because anytime we see I, we should be thinking imaginary. The real part is going to be the a, because it doesn't have the I. And we always want to write these together with the real part first and the imaginary part second. A plus bi. That just tells us what order we want to write the numbers in. So the next question, or the first example, says, write this fraction in standard form. So we're going to break this fraction apart, and we're going to do 6 over 2, and then we're going to do 4i over 2. Now we want this in the form a plus bi. That's why we're going to write our I term second. And that's going to give us 3 plus 2i. Now, if we were naming the a and the b, a is going to be the real number that doesn't have the I, so a would be 3. B is going to be the number that does have the I, so B would be 2. The I is not included in the B, it's just attached to the B. So now our next example says the square root of negative 45. So anytime you see a negative under a square root, and remember our index here is a 2, that's how we know it's a square root. This negative is going to come out and it's going to turn into an I in front, and then we're still going to be left with positive 45 underneath our radical. Now, if you're still breaking this down using a factor tree, it's going to be 5 times 9 and 3 times 3. So we have I square root of 5 times 3 times 3. Remember, when your index is a 2, you're looking for groups of 2. We have 2 3s, so a 3 can come outside. We have 1 5 by itself, so that's going to stay underneath the radical. And this I is going to be multiplied by that. So now we get 3i with the square root of 5. Now, I think when you put your answer in on your homework, you might need to do 3 square roots of 5. And then make sure you push the arrow button to move over 1 space from here. You're not going to put a space. You just don't want the I to be under the radical. You want to make sure that you take this outside of the radical if you write it at the end. So this part is in front of the I, and the I comes after you close the square root. So if we were looking at this in the form a plus bi, and we have 3 square root of 5i, then that tells us that a is going to be 0, and that b is going to equal 3 square roots of 5. Okay, the next one. Here we've got a double negative happening. The negative on the outside doesn't do anything to what's under our square root. So we're going to keep that negative hanging out in front. And the negative that's under the radical is going to come out, and it's going to turn into an I. And then we're left with 147 under the square root. So now we can do our factor tree. 147 breaks down to be 3 times 49. 49 breaks down to be 7 times 7. So we end up with negative I square root of 3 times 7 times 7. And again, our index is a 2, so we're looking for groups of 2. So that shows us a 7 can come out. A 3 is going to stay underneath. And this negative I drops down into our answer. So we have negative I times 7 with the square root of 3, which becomes negative 7i root 3. Or we're going to write it as -7 root 3 with the I at the end. Now, if you want, you can always put multiplication in between these two. So that way you know that you're multiplying here and that I is outside of the radical, but attached with multiplication. Now, if we looked at this as A plus BI, then A would be 0. We don't need a plus because our B is negative. So that shows us we've got A equals 0 and B equals -7 root 3, which is always going to be what's in front of the I. Okay. This next one, we've got two radicals, and we're told to express our answer in terms of I as a complex number. So we know that we're going to have an I in there. So when we look at this, the first thing that we should see is this negative is going to come out. It's going to turn into an I. This negative is going to come out and turn into an I. And we're going to end up with I with the square root of +3 times I with the square root of 48. And then we're going to multiply the parts that match. So I times I will give us I squared. Remember, this is I to the first and I to the first. They're matching bases. So we are going to add those exponents. That's where we get this 2 from. Then we're going to take what's under the radical and we're going to write it together. Now, we could multiply this and then do the factor tree, or we could multiply it and see if it's a perfect square. So if we were to check that, we get 3 times 48 is 144, and 144 is a perfect square. So the square root of 144 gives us a 12. So then we end up with 12I squared, but we have to make note and remember that we replace I squared with a -1. So that's really 12 times -1, which is -12. Now, you can't multiply these two together before you take the i's out. So you have to take the I out first. Right, so we want to do that first, or we're not going to have the right sign when we get to our answer. Now, some of you might be doing these problems this way. If you got to this step here and you thought, well, let me break down that 48. Maybe I can do my factor tree and get to an answer that way. So 48, you could have done 4 times 12. 4 is 2 times 2. We've got a 2 times 6 and a 2 times 3. So we've got a lot of numbers over here. So we have this I here should have a square on it. I forgot to write that square. You see it over here. So let's go ahead and add that square in. It's I squared. And then we've got I squared with the square root of 2 times 2 times 2 times 2 times 3. And since our index is a 2, we've got 2 2's coming out. We've got 2 2's coming out. And then we've got 2 3's. Don't forget this 3 here. I forgot to write that one under my radical. but that gives us 2 3s also. So we've got a 3 coming out. And then this I squared still turns into a -1. So now we have -1 times 2 times 2 times 3. And that's going to equal -2 times 2 times 3 is -4 times 3. And we still get -12. So it's fine if you're still doing the factor tree this way. And it's fine if you try multiplying first here and seeing that you've got a perfect square with 144. Okay, this next one, we're going to use some rules that we've talked about in the past. So the first thing that I want to point out is we've got the square root of -1 over the square root of -1. Now, if we go back for a second, what is 5 divided by 5? Right? That equals 1. We've got -10 divided by -10. That equals 1. The square root of 4 over the square root of 4. That equals 1. Anytime we have something divided by itself, it equals 1. Something divided by itself equals 1. And something divided by itself, it equals 1. So when I look at this problem, I see something divided by itself here, which is going to equal 1. So those cancel out. Then we're left with 1 over the square root of -6. So now we can take this negative out and we're going to turn it into an I. Remember, you've got to take that I out before you do anything else to that problem. Now, if you don't like it that I didn't take the I's out of the -1s, we can look at this a little bit different of a way before we finish it. Right? We could take these negatives out, turn it into an I, turn it into an I, and we would end up with I square root of 1 over I square root of 1 with the square root of, let's go ahead and take out the I on that -6 also. And then we would end up with I square root of +6. And you would see the square root of 1 is just 1. And the square root of 1 is just 1. So we get I over I times I root 6. And you'll see that we've got an I on top and an I on bottom, so they cancel. And we're still left with 1 over I square root of 6. So this and this end up simplifying to be the same thing. We get 1 over I square root of 6 here because this negative comes out, turns into an I, and then it makes this 6 positive. Now, we're going to finish this question. So we have, let me move some more of this out of the way. So we learned about rationalizing the denominator. We're not allowed to have a radical or an I in the bottom of our fraction. So we're going to have to take this and we're going to have to multiply it by I root 6 over I root 6. Now, what is anything divided by itself equal to? So we know that this fraction here equals 1. So we're really just changing the format of this fraction, not the value of it. So when we do this, we end up with, let me move this again. We end up with top times top and bottom times bottom. So we've got I root 6 on the top, and on bottom we have I times I, which gives us I squared, and then we have root 6 times root 6, which just equals 6 without the radical. So now we can take this I squared and we can replace it with -1. So we get I square root of 6 over -6. And that's going to be the same as negative I root 6 over 6 with the negative on the bottom or in front in the middle. So let's do this again, just so we can walk through it one more time. We're not allowed to have I or a square root on the bottom of our fraction. So for us to get rid of that, we're going to multiply by I root 6 over I root 6. And then we do top times top, bottom times bottom. So we get I square root of 6 over, and that's going to be I times I, which gives us the I squared. And anytime you get I squared, we're going to replace that with a -1. That's how we get rid of the I on the bottom. We want it to be I squared. Then we have the square root of 6 times the square root of 6, which just equals 6. So now we're going to replace this I squared with a -1. And that's going to give us I square root of 6 over -6, which is the same thing we just did. Okay, so this next one, we have subtraction, and we're asked to write it in terms of I, which means we need to write it as A plus BI. So we always have to write the real part first and the imaginary part second. So now we can take out the negative. It's going to become an I. We're going to take out this negative. It's going to become an I. So we have I square root of 100 minus I square root of 64. And now we have perfect squares. We've got the square root of 100, which is just 10. So we have 10I. Then we have the square root of 64, which is just 8. So we end up with negative I, negative, let's write it as 8I. So it's always better when we put our number in front. And so now we have like terms. Notice we've got I to the first and we've got an I to the first here. So we're going to get 10 minus 8, which is 2I. We are not multiplying these, so we don't change the exponent. These are like terms, just as though it was 10x minus 8x equals 2x. So we treat that I just like a variable. The different part is it can come out of our radical starting as a negative and turn into an I. Or if we get I squared, we replace it with -1. That's just the difference between the I and the x. So now if we were looking at this in the form of A plus BI, then we would have 0 plus 2I, and we would know that A equals 0 and b equals 2. So that is our final answer. Okay, the next one is an addition problem. We're going to pretend like we have to go through all the steps, even though it's a positive 1, right? We've got an imaginary 1 here. If this was a negative, we would have to distribute a negative. We're going to pretend and we're going to distribute a positive. So we end up multiplying by positive 1. So we get 4 plus 2i. 1 times 6 is positive 6. And then 1 times negative 7i is negative 7i. So now we're going to look for like terms. We have 4 and 6 which match. And we have 2i and negative 7i that match. So we want to write this in the form of a plus bi. So we're going to put the numbers first. So we've got 4 plus 6, which gives us 10. And then we have 2i minus 7i, which gives us negative 5i. So this question does ask us the real number a. A is going to be the real number part, which is 10. And then b is going to be the number in front of I, which equals negative 5. Now remember, this sign is attached to the b. So if this is negative, b is going to be negative. If that were positive, then b would also be positive. Okay, we've got one more page of notes. This question does have a negative in it. So we're going to do a couple of things here. I want to go ahead and take out the negatives and turn those into i's. So we know that happens. And I want to talk about this negative 1 here because we're subtracting. So we're going to distribute a negative also. So we've got 16 minus I square root of 100. Then we've got a negative times a negative, which gives us a positive 6. And then we've got a negative times a positive, which gives us a negative I square root of 49. We know the square root of 100 is 10, and the square root of 49 is 7. So we're going to write this as 16 minus 10i plus 6 minus 7i. Again, we're going to look for our like terms. We've got 16 and 6. And then we have negative 10i and negative 7i. So we can combine those. We always want to write the real term first. So we're going to write the a first. So we've got 16 plus 6, which gives us a 22. And then we have negative 10i minus 7i, which gives us negative 17i. So if we were looking at this, a would equal 22 and b would equal negative 17. Now, if we're not asked for a and b separate, this would be our final simplified answer. Okay, the next one, we're going to treat this just like it is 5x minus 2 plus 7x. So when we see an I, we treat it just like we would a variable. Okay, so we're going to distribute 5i times negative 2 is negative 10i. Then we have 5i times positive 7i, which is positive 35i squared. We know, we've got positive 35i squared. My squared didn't write. So we know anytime we see I squared, we're going to replace that with a -1. And when we do that, since these two are touching, it's multiplication. These need to be multiplication also. So we end up with -10i minus 35. Now, this needs to be written in the form a plus bi, so we're going to have to rewrite this with a first, where a is -35, and then our b is going to be -10, and we're going to keep the I attached to it. So now this is in the same form that we need, and that would be our final answer. I think this might be our last two questions. Here, we've done a couple of these. This is going to be a FOIL question, or if you use the box method to keep it organized, that's fine. You just need to make sure that your answer is a plus bi. Anytime you have a problem with an I in it, this is the format you need to write it in. So we're going to multiply here. -4 times -4 is +16. -4 times -5i is +20i. Then we have 5i times -4, that's -20i. And then +5 times -5 gives us -25, and that's going to be I squared. Remember, when we multiply I times I, we add those exponents, and they're both an imaginary 1, and that's where we get I squared from. So now we have like terms here in the middle, I to the first and I to the first. Those are opposites, +20i and -20i, so those are going to cancel out. And we need to make note that I squared needs to be replaced with a -1. So this becomes -25 times -1, which makes that a +25, and 16 is still 16. So now we have like terms. We can add those two numbers together, and we end up with 41. Notice all of the i's canceled. So we don't have any i's in our question. These two middle I terms canceled, and I squared is replaced with -1, and that gets rid of the I in this term. Now, we did briefly talk about what a conjugate is. If you look at this question, it is -4 plus 5i and -4 minus 5i, which those are called conjugates. Remember, a conjugate is when you change the middle sign. Okay? So this last one says, simplify the following expression. Give your answer in the form a plus bi. So we're going to look at this. First things first, we've got this negative that needs to come out and turn into an I. So we've got -8 plus I square root of 4 over 6. We know the square root of 4 is a perfect square. So we end up with -8 plus 2i over 6. The square root of 4 is 2. It makes more sense to write that as 2i instead of I2. It's weird when we put the variable in front of the number. So we're going to put the 2 first. And then we're going to take this, and this needs to be in the form a plus bi, and that's not what we have right now. So we're going to do this fraction, negative 8 over 6, and then we're going to do positive 2i over 6, and we're going to simplify those separately. So we have negative 8 over 6 plus 2i over 6, and both of these are divisible by 2. So we're going to divide by 2 here, and we're going to divide by 2 here and here also. So we're going to end up with negative 4 over 3 plus 1i over 3. Now, this is 2 divided by 2 here, and that's going to equal a positive 1. And since we needed an a plus bi, we're going to write it as 1/3 with the I next to it. So that shows us that A is negative 4/3, and then it shows us that B is 1/3. So having that I written on top of the fraction or beside the fraction is the same. You can't write it on the bottom. That is different. So that wraps up the last section for test 2. Make sure you get started on the test 2 review. You need to do that before test 2 happens.